What are the discerning features of high-rise structures, especially in the Indian context? And what are the new innovations? How does your consultancy? And from now, software, I'm moving to new materials. And these are becoming common. There are other things also that are kind of coming up new in terms of, new materials. So anything, you think new engineers and people in the construction industry should be aware of, anything that is there on the anvil that... Hello and welcome to CQRA Podcast. CQRA is one of the leading companies in the country for construction quality, safety and QS audits. And CQRA Podcast is where we get you valuable insights from construction industry leaders. I'm your host, architect Shruti Hussain, and today I'm very happy to have a stalwart with us from the construction industry, Mr. Umesh Joshi, who is the partner at JW Consultants, Pune, which was formerly known as YS Sane and Associates. So welcome, sir. We are very happy to have you on the CQRA podcast.
Many thanks, and it's my pleasure to be part of this podcast.
So just to begin with, you have really seen the journey of the construction industry in India, not just in Pune, and you have been part of this legendary firm, YS Sane, and it has a great status not just in Pune but beyond. So you've been part of this journey, you've seen the way buildings, the whole construction infrastructure has come up, you've been part of various committees where you've seen the evolution of codes and drafting of regulations in the industry, with academia and sort of industry collaborations. And just recently, you've been part of the committee of drafting seismic codes in collaboration with IIT. So, first things first, I'm just getting to the very pertinent point right now. So can you tell me why the revisions in the seismic codes matter? And, in the light of all this increased infrastructure, not just building, but we have bridges, metros, all sorts of things coming up. So why does it matter?
Just two things, a small correction to start with.
Okay.
I'm not formally a part of the drafting committee, but we had been informally consulted by the code writers, and we are happy to contribute whatever we can as a part of the profession. And that interaction goes a long way in terms of understanding where the academics and academia is thinking about this issue and where we will have some difficulties in terms of implementation. So that dialogue, in my opinion, is extremely important, and that's what we are trying to maintain with the code writers and the Bureau of Indian Standards.
All right.
Now, to answer your main question, that earthquake engineering, now let us talk in terms of seismic codes, and the basic code had been IS 1893. Now, seismic engineering is one such science which had been evolving over a period of time. In a sense, if you go back to the history, this IS 1893 was first published in 1962.
Okay.
Then the second revision came in 1975, if I were to correct. Yes, 1975. Then the third came in 2002.
Okay.
Fourth in 2016, and now fifth in 2025. So even though people in our country are feeling that these are just too frequent revisions, it's not the case. Honestly, overseas in advanced countries, if you take for that matter ASCE or ACI, ACI keeps on revising codes every 3 years. While 1962 to 2025, that means in 63 years, we had just had 5 revisions. So we need to brace up for more advancement in knowledge. And what we are trying to do, that we are now trying to align ourselves with the international codes. So even though people at large are feeling with a bit of dismay and shock, or just too many revisions happening, it's not the case. And in case of an evolving science and with developing technologies, this is bound to happen. And this is needed for the industry.
Right, that's true. And, to keep up with the international standards, that you need to have at least, 3 revisions per...
in a sense, once in 3 years usually, once in 3 years, that had been the international norm, especially with the American codes. Not so much with the Euro codes, but even they are trying to keep up, because the understanding of earthquake engineering is evolving day by day. So possibly what we assumed that to be correct in 1990s is no more, I won't say valid, but it's not accurate in that respect.
Okay.
So, and we need to then look towards improvement. So, we have to welcome these revisions and we'll have to keep up pace with this.
That's right, that's right. And it kind of makes sense considering that a good part of the country comes under, very earthquake-prone zones. So these
Yeah. You are asking me about a relevant question for the simple reason that there had been revisions. Just to highlight for people in the industry to know that, especially the revision which has happened in November 2025,
Okay.
the hazard levels of the code have significantly changed.
I see. Okay.
And in a sense, we sitting in Pune and Mumbai are not to that extent affected.
Okay.
But cities like Ahmedabad,
Right.
now Ahmedabad was in zone 3.
Okay.
Irrespective and after even the revisions after Bhuj earthquake. But now it has been upgraded to zone 4. That means highest seismic hazard.
Yes. Okay.
Same is the case with Calcutta.
All right.
And the more striking case is in case of city of Chandigarh. Chandigarh was in zone 4 till 2025. But they have few geological faults around that area.
Okay.
And for the first time, the highest zone has been created, which is zone 6, which was not there. And Chandigarh has jumped straight away from zone 4 to zone 6.
Oh, really? This is something that I think
Many people would know right now. So there is a significant change in zoning and as well as the hazard levels.
Okay. So this changes a lot of things for
This changes, yes, this changes quite a lot of things. In a sense, the revision of 2025 focuses more on assessment of hazard in a more objective way.
I see. Okay.
If I were to elaborate it, that we were talking in terms of earthquake hazard by citing of one credible large earthquake. So that we used to call it technically, without going too much into mathematical part of it,
right,
that it's a deterministic way of defining hazard.
Yeah.
Then 2002 to 2016, we went a step ahead and we went to semi-probabilistic.
Okay.
And now we are taking advantage of various geotechnical investigations which have happened over a period of last 20 years.
Okay.
And statistical sciences also. Okay. And we have gone now to what can be called as a probabilistic seismic hazard.
I see.
And it has changed completely the way in which you will think about earthquake and design calculations.
Okay, so that was absolutely, informative to our viewers.
Yes, and that is, we are trying to align ourselves with advanced codes like ASC 7 or Eurocode 8. That means we are not exactly there, but we are almost reaching there.
You're reaching there.
We are reaching there. We are reaching there.
These questions about, seismic codes also are pertinent because we're seeing a lot of high rises right now. Especially, I have these figures. There are more than 416 building proposals in the pipeline with heights ranging from 150 to 300 meters in Mumbai.
Which area you are talking of?
In Mumbai metropolitan region.
That's right. That's right.
Yeah. And, a 400 meter high building is also in the works. And you have been part of two very iconic structures in Mumbai. One is in Tardeo, the 60-storied Imperial Tower, and India's first 90-storied structure, the Minerva Towers at Mahalaxmi.
That's right.
So these were really, some landmark kind of buildings. So in the light of all of this, I want to ask you, what are the discerning features of high-rise structures, especially in the Indian context? And what are the new innovations? How does your consultancy handle them?
So there are two aspects. The high-rise design, of course, will derive its basis from seismic provisions that we will be bound by the Indian standard codes. Not only seismic, because we keep on concentrating on seismic, but here I would like to highlight that once you start going above 150 meters, along with the earthquake, wind starts playing a very dominating role.
Right.
As a matter of fact, buildings in excess of 150 meters, the upper levels are dominated not so much by the wind, not by the earthquake, but it gets dominated by wind.
Okay.
And that's why wind tunnel studies on actual model, they become very important in terms of understanding the behavior of the building.
Okay.
And further, we didn't have a code on high-rise buildings till 2017.
That's very fair.
There was not a uniform definition of high-rise.
Okay.
In the sense that if you are from Mumbai till 2000, maybe 18, high-rise definition was 70 meters and above. That means high-rise building was defined as buildings above 70 meters.
All right. Okay.
Now it has been revised to 120 meters and it will be eventually revised further.
Okay.
If you come to Pune, then it was 70 meters. Now it has been revised to 120 meters. If you go to Ahmedabad, they will start calling anything above 45 meters as high-rise buildings. So depending upon the contextual buildings surrounding, the higher definition kept on changing.
Changing city to city. Yes.
City to city. Now for the first time, Bureau of Indian Standards have codified it and they have brought in a code in 2017 as a tall building structures. Right now, it details out on for concrete buildings.
Okay.
Now the work is in progress for devising these codes for composite buildings as well as steel buildings. But right now what we have available in our hand is for concrete buildings.
All right.
And they have for the first time defined that the building set between 50 meters high to 250 meters will be termed officially as tall buildings.
I see. Okay.
And anything beyond 250 meters, you just refer to 300-meter high building.
Yeah.
That is not covered by the code, but they say that you will have to go to a more specialist committee to get it approved.
Okay.
So what is called as code exceeding approval, that is something.
All right.
Again, that's a new concept which has come through BIS, that they are talking of allowing something which is code exceeding. So that's a revolution. And I seriously and honestly welcome the openness with which the code has accepted that there could be something beyond the codes which have been written. And they have recognized that fact and we have a committee in place now to approve those buildings. But we have now at least uniform definition for the country as a whole.
Right. So that gives probably more space for experimentation, in terms of design and
experimentation, yes and no, honestly.
Okay.
Because 16,700 is more of what you can call as a prescriptive code.
Okay.
It doesn't depend so much only on the analysis, but it also says that look, if you want to design a building in Delhi, which is of 180-meter height, the framing has to be of this nature only. That means you need to have shear walls in the part of the framing. You simply can't go with the column and beam. If you are going above 200 meters, then you will need to have structural elements like tube in tube.
Okay.
If you are wanting to do a slender building, then you need to have specialist elements like outriggers and belt trusses. You could then think of using dampers also. So, to some extent, yes. To some extent, no. There are some restrictions also.
Right. Okay. That was exactly my next question, that, there are technologies like belt trusses and you have outriggers, you have tuned mass dampeners, things like that to,
these are not technologies, these are structural framing options.
Framing options and even no.
Yeah, just for a common man to understand that. What do you mean by a belt truss? See, many times we hear in our colloquial language that if you want ask to somebody to really brace up to a situation, we say pull up your socks, tighten your belt.
Tighten your belt, yeah. Brace
so when you say tighten your belt, that means what you are trying to do. When you are tightening the belt, you are making that man strong enough, stiff enough to resist whatever additional forces which are likely to come. So similarly, the name belt truss has come. That means you have a stiff element around the building perimeter, which will hold the slender building to resist the force of wind, extreme wind. That means the wind will create large accelerations, and to control those accelerations, which will make person otherwise feel sick. That means if you don't control those accelerations, you will feel that you are constantly on a sea.
Yes, you'll feel seasick on the building.
Seasickness, which otherwise people experience.
True.
As a matter of fact, on few tall buildings in US, for example, if you go to Chicago, on the famous tower over there, if the condition is extremely windy, they don't allow you to go up on the observation deck as well.
Right.
So nowadays, there are good examples of now tuned mass dampers also,
Okay.
which incidentally we have designed one in consultation with wind engineers like Windtech and RWDI.
All right.
And that is something we have provided on a very slender building that we have designed in Calcutta.
Okay.
That is called as 42, and that has a slenderness ratio of 13, which is fairly slender.
Okay.
And it got tested to some extent because after the building was completed within span of 5 years, we experienced, if you remember, there was an Amphan cyclone, which Calcutta experienced.
Right, so strong wind.
And those tuned mass dampers worked very well, honestly.
Okay, that's great.
We had virtually no damage to the building at all. That means, in spite of that building being slender, we had no issues on that.
Are there any other techniques apart from these time-tested?
See, tuned mass dampers is in the form of well-designed water tanks strategically located, which will balance out the oscillations by the wind.
That's right.
There are further dampers available in the market, which are for either for earthquake as well as for the wind.
Okay.
Those are called as viscoelastic dampers.
Okay.
So those also will be used. But till today in India, not many dampers have been used because we have still not gone the way the developed world has gone in terms of devising slender buildings.
There are now new software, for structural building analysis. There is BIM, and there are a host of other, software which are available for structural engineers. And in the future, maybe there'll be something that is going to be AI enabled. So how do you see this kind of transition? In your opinion, will AI become an integral part of structural design? And what is its impact going to be on, this whole design process?
This is like an evolution, because as I said, I started my career with slide rule.
Yes.
Okay. Even I didn't have a calculator when I did my post-graduation, leave out any other things.
Oh my God, all right.
And from there, we have come to these computer techniques in a period of 50 years. I still believe the man behind the machine is going to be most important still. You will get AI, but the prompts that you give to AI are going to be equally important. If you give a wrong prompt, you will get garbage out. So essentially, the man behind the machine cannot be replaced.
Okay.
On the contrary, the man behind the machine will have to raise his level of intelligence to ask an appropriate prompt. Because if you are not up to it, see, it was easy to work with slide rule because there was certain amount of approximations involved. Now we are no more talking of approximations. Now we are talking of pinpoint accuracy. And to get a pinpoint answer, your prompt or your question posed has to be pinpointed. And to give that pinpointed question, the person who is using that AI will have to be, to that extent, better educated and articulate in terms of asking a question to get a correct answer. But to tell you, yes, all these softwares, you mentioned about BIM. BIM is a revolution in terms of drafting. Let's put it this way. BIM is an enabling software which will kind of help us in detecting various clashes that we might get while we are designing the building. Then we also, when we go to level 400, LOD 400, we also will detail reinforcement. Then we will also understand more clearly the congestion part of it.
Right.
Then there are time elements also involved. You get the quantities out also.
Yes.
So all these things will go step by step.
Automated, basically.
Automated, completely automated. But what it will mean? It will only mean that you are going to more and more refinement. I will just give you an example that when we were drafting manually, possibly if I had to create 2 alternative plans, it took any architect 7 days, 10 days.
Yes, easily.
With AutoCAD, possibly you can create 4 alternatives if you have that kind of a creative mind which can work quickly. So the mind has kept up with the machine. In the sense, the moment we have advanced software, people using that software have become that much fast. And that much of additional alternatives are becoming available, that too quickly, and which we are able to analyze now. Now, when we are creating all these alternatives, we also need quick computational tools.
Yes.
And these AI will help us in getting there much faster than what we can. It is going to help us in terms of eradicating mistakes where, a human being can make mistakes when the work is of a repetitive nature. Because when we are designing a large size building, there are elements in the sense that in a given floor slab, there could be 300 beams, there could be 80 columns or 80 shear walls and 80 levels of that. That means you will be detailing out so many joints and so many beams. And many times after you analyze the structure, it's a repetitive work. And there AI will come to your help to eliminate your errors. The moment your concentration is now taken away, that you are no more required to concentrate on looking into those drafting and manual things, possibly creativity will still go up. Because man will then start looking into more creative ways of designing buildings. Because his energies now will be available for better creative work.
Yeah, that's an interesting way to look at it.
Yeah.
And is your office also using AI in any way? Have you?
Yes, slowly we have. But nothing to write home about at this point of time because, all of us, are in the initial stages.
Okay.
We are learning the ropes in a way. We are also trying to create some what we call as post-processor program. That means after analysis is complete, using AI. But that is in the development stage. But it's not going to be far away. In a sense, I'm looking to it in terms of development in next 6 to 12 months, that we should be equipped to some extent with that.
Okay, I see. But I think that's an encouraging kind of outlook that you've given, because people are worried about AI, especially in the design, that it will take away human
Everyone
jobs.
was worried. See, every time the new development came in.
Yeah.
See, when the computers came in, people said that people will become jobless.
Yeah,
Has anyone become jobless? No. There had been more jobs in the market.
Right.
So, any new technological development, it's a monster. If you don't handle it, then it will overpower you. So, that's why I'm saying that man behind the machine or someone who is using that technology will have to get better equipped to master it. Right. If you don't master it, then
it will master you.
It will master you. Yeah. And then you are, as I said, I'm looking to AI more in the form of that it will take away the efforts from any human who is designing building from monotonous work or repetitive work. Because most of the time when you are designing complex structures, there are going to be monotonous calculations which are going to be involved. If that is going to be eased out by AI, then obviously I can devote my time and energy towards more creative work. And that's where AI will come to our help. That's my firm belief.
That's good news.
We have to handle it carefully, that's all.
Yes. And from now software, I'm moving to new materials. And we have, materials like ultra high performing concrete, and there is fiber reinforcement, carbon fiber reinforcement or glass fiber. And these are becoming common. There are other things also that are kind of coming up new in terms of, new materials. So anything, you think new engineers and people in the construction industry should be aware of, anything that is there on the anvil that, is going to kind of, be a very important, maybe a
As I said, yes, we are at the cusp of something happening which is going to be different than what we had been working with. However, in our country, we will have to emphasize more on testing.
Okay.
And what I will say that full-scale model testing, because that is something we are still way behind the Western countries or Japan. because they do a full-scale testing. That means if I were to tell you that they construct even virtually a ground plus 2 structure to be tested on a shaking table to see the seismic performance. Now we are getting into that domain in a very small way. Couple of experiments are happening over there. Because we cannot follow blindly what is written outside. Because when we are talking of concrete, eventually concrete is made out of material which is locally available.
That's right.
Your aggregate is different, your sand is different, your cement may be of international standards produced, but even eventually your quality of clinker will differ from place to place. So we will have to create experiment, because in terms of, you did make mention of UHPC. Now UHPC is the grade of concrete which we are looking way beyond 100. That means 120, 150 grade concrete. Right now, just to make people aware that since we are in seismic zones, these high grade concretes have some problem in form of ductility, which is required for the structure. Now ductility is something which is required for the building to behave in a more robust way in case of a seismic event. And simple way, because many times people ask me, people confuse between ductility and flexibility. Ductility is something which will allow the structure to deform adequately under an extreme seismic event without actually collapsing. Because as a structural engineer, howsoever I wish, I can't promise you earthquake-proof structure. I can give you earthquake-resistant structure.
That's the word.
So that means in case of an extreme event, we do anticipate large damages.
Breakage.
But we talk of collapse prevention. In a sense, our performance guideline tells us that in any case we have to avoid collapse. Damage is an extreme event, can't be ruled out. So when we talk of ductility, that will mean that the occupants of the building should have adequate time
before
to come out of the building, to escape from the building, so that there is no loss of life. Because all engineers possibly and everyone in the industry should worry about the loss of life, and that is something is absolutely no. We should have zero loss of life. That is the first and most important priority. So that is something what we are trying to do. So UHPC still has a long way to go in terms of establishing the ductility, because there are certain issues in terms of strain compatibility, and that is something we will have to work upon. But otherwise, in certain other areas where you are not talking of earthquake resistance, you could be using UHPC in a very big way. Coming back to the glass fiber reinforced, you also did mention about that. Glass fiber reinforcement has a limited application, more in case of pavements, runways, roadworks. Again, coming back to the seismic requirement, it has what we call as percentage elongation, which is very low. That means it will not perform well in earthquake scenarios. Just to give everyone an idea, that we are looking at that value of around 14%, while glass fiber reinforcement will have in the range of 4 to 5. So that will not be in the accepted range. So there will be limitations in terms of use. But carbon fiber reinforcement is being widely used in terms of wrapping. So in terms of strengthening structures and augmentation of structures, we are widely using carbon fiber reinforcement, which is used to confine the existing columns which you want to augment in terms of its capacity for the compression. So that is something which is being widely used over the last 10 years.
All right. And anything else, anything other than what I've mentioned that you
as I said, overseas, when we travel overseas, people have been talking of very high grade of concrete with a very high ductility. But that is still in an experimental stage. So me as a structural engineer, I am looking forward to getting hand on those materials, because then to that extent our job will be challenging but easy also, because we will have wider variety of materials available.
It's interesting, but we still have a long way to kind of go to.
In a sense, the materials that you are talking of, the UHPC and the glass fiber,
Yeah.
I just cited
Yes.
the limitations of them.
True.
But we will have to now develop materials overcoming these limitations so that you will be able to utilize these materials more effectively.
I see. Okay.
So that is a way to go, honestly.
So in your, entire career, you've seen, all kinds of developments. You've, especially, say, when you talk about the city of Pune, you've seen from a low-rise community kind of living to now we have high-rise, fast-paced living. And you've been part of this legendary firm, YS Sane and Associates. So in your journey, I want to ask you about any particular project that has really stayed with you, something that was, that you had
Those
great
are many
learnings.
projects. So
Okay.
I have
Can you
been
tell us
fortunate
one?
enough to be part of
I'm
maybe
sure
at
many
least 10,000
significant.
projects so far.
Okay,
So
wonderful.
to name
That's-
any one would be injustice to someone else.
Okay.
But as you rightly said, the evolution had been over a period of time. And the few jumps that you take, that as you rightly pointed out in the 80s, we were a ground plus 2 city,
Right.
kind
Yes,
of.
yes.
Bungalows and ground plus 2, ground plus 3 at the most.
Yeah.
From there on, in 1987, we first got our hands on a 15-story building
Okay.
in Mumbai. For us, that was a high-rise building.
Yeah.
See, today you will laugh at me if I'm talking 15-story building as a high-rise building. But it was like a challenge. From 87 to 97, we were around 15 to 20 stories.
Okay.
Then suddenly when we went to 100-meter high building, again that was a quantum jump for all of us.
Sure.
Then 30 stories to 60, 65 stories in a space of 5 years. No, thereafter the pace had been rapid. In a sense, it took first 30 years and then every 5 or 7 years we are going ahead. Now we are talking in terms of not only height, but very large spans,
Yes.
very long span
Long
beams,
spans, yes.
long span beams. So every project which involved these problems had its own challenges.
True.
Just to cite an example, we did, if I have to name something, that we did a pyramid structure for Osho Ashram over here.
Okay.
Now, that time, this we started doing in 87. And it was 110 feet by 110 feet. So, that time it was a very large, and
Large span, yes.
architect didn't want any columns and beams in between.
I think it was Hafiz contractor.
Hafiz contractor, that side. And that was based on the theory of that all mummies which have been preserved in Egypt are under a pyramid of 55 degrees with the horizontal. The pyramids were having an angle of 55 degrees.
Yes.
So all those pyramids have been done, if you observe,
Okay.
with a 55-degree pyramid.
I see.
Now that time, designing was a challenge because we didn't have many softwares available then in 87.
Yes.
And construction was further a challenge. Because as you would appreciate that, how do you cure a structure going up on a 55-degree slope?
Yeah.
So we had to start thinking in terms of basic construction things which we can do. These are no more a challenge now. Because now concrete testing, where I'm sitting in CQRA,
Yes.
which is in part because they had been able to bring in all those equipments. The only non-destructive testing which was available to me was a carpenter's hammer and my ears.
Yes.
Putting my ear to the column and hammering the
How does
column
it sound?
to understand the quality of concrete. So from that we have come to such a level of testing. So all these to me are landmarks. So rather than to cite a particular landmark, these evolutions, yes, have been fortunate to go through those 50 years virtually now. It's now my 50th year in the career. So it had been a great experience and a great learning curve. And this learning curve doesn't end. That means whatever I have done 10 years before, possibly some new structure will pose more different issues.
Right. That's really remarkable, to kind of see this sea change.
Correct. I said I consider myself to be fortunate to see this change.
We just now spoke about your, journey in the past, encapsulating all those remarkable events, landmarks that have happened in the construction industry. But I want to ask you now, how do you see the future of construction? And what would you tell to the budding future construction industry professionals?
Future is basically contextualized by the country that you are living in. The context for us would be different. Context for USA will be different. Context for China will be different. So let's focus on where we live, India. And we had been essentially a concrete-centric industry, kind of. So far, if you see the incidence of structural steel in building works is comparatively smaller in number. The total, if you just go around on street in Pune, Mumbai, you may not find more than 10 or 12 buildings which are made out of structural steel.
Yes, very true. You hardly see anything.
You hardly see anything. So I still see that, especially in the commercial field, I see a lot of scope in development, because structural steel is another material which you can utilize properly, but it is a bit expensive for the Indian pocket right now, in a sense that still at the end of the day, even though how much optimally you might design it, it will cost you 15 to 20% more.
Right.
But it will cut down on your construction pace by almost 30 to 40%. In a sense, it will enhance the pace. So your construction schedule can be reduced by 40 to 50% virtually.
That's
so more and more buildings become commercially viable to be finished quickly, so that you start getting return on investment quickly. People should be willing to spend on that additional capex.
Okay.
So that is something I look forward to. As I said, I also look forward to eventually aligning ourselves with the international market, because theoretically we are trying to be there, but we have a bit of way to go in terms of achieving that final construction finesse in terms of quality. That means uniform quality anywhere and everywhere you go. You should be able to get that uniform quality. I think we all engineers need to strive towards perfecting that construction technique. That means even if I am constructing a single-storied bungalow or I am constructing a 100-storied tower, my construction quality will have to be of the same grade. That is something we all need to learn and equip ourselves mentally. As I said, we are there in terms of knowledge and we are there in terms of materials also. I always say that mental makeup has to be improved. That means, in the sense, I would rather neglect a low-rise structure and pay more attention to high-rise. That should be out of the window. We should be able to produce the same quality everywhere.
Across whatever
across any typology that you do.
And paying attention to execution.
Correct. And thirdly, just remove that myth from the civil engineer's mind that theory and practice are different. I have been always emphasizing with the college students that somehow people had been talking of, whatever you learn in college is of no use in practice. No, it's not that way. Our civil engineering industry suffered for a long time because we carried on that myth as a gospel truth. That whatever we are taught in colleges is not applicable.
You have to unlearn.
No, we have to unlearn, because we have to simply forget it. And that is the reason civil engineering, amongst all engineers, had remained at a lower rung as compared to other industries. Because we tended to neglect the theory part of it. Your mind has to be agile enough to apply that theory to practice. And I am looking forward to the next generation to improve upon our generation in terms of that.
That's wonderful, yes. And you have given us such wonderful insights, right from earthquake-resistant buildings, seismic codes, and coming from this kind of legacy background that you have, and giving us like a whole wrap-up of the Indian construction industry, how it has evolved. So it's been a wonderful chat, sir. Thank you so much for being on CQRA Podcast. And
for me personally, it had been a wonderful journey, and thank you for inviting me to CQRA Podcast.
I'm looking forward to more such conversations. Maybe we can talk again sometime.
That's right. We can talk on whatever I have learned. I will be very happy to share.
So great resource. It's a repository of knowledge that we all need to kind of, bank on. So thank you, sir. And, do join us again for our next episode of CQRA
Grateful,
Podcast.
grateful to everyone.
Thank you.
Thank you very much.